Go along, if you have any questions, please feel free to enter them into the questions tab
today, titled Adaptive Signal Control with Miovision and Rapid Flow. My name is Brian Barg, and I'm the Ontario Account Manager for Stinson ITS. And today's discussion will be how Miovision's traffic solution in combination with Surtrac's adaptive traffic signal control from Rapid Flow Technologies optimizes signalized intersections in real time. Using TrafficLink's multimodal video detection data, Surtrac minimizes delays while prioritizing modes of traffic based on a city's objectives and use cases. Now, one quick housekeeping note, as we go along, if you have any questions, please feel free to enter them into the questions tab in the sidebar of the webinar window, and we will address them at the end of the presentation. Now, today's presenter is Greg Barlow, and he is the founder and Chief Technology Officer of Rapid Flow Technologies, an intelligent transportation technology startup based in Pittsburgh, Pennsylvania. He is the co-inventor of the Surtrac Adaptive Traffic Control System, originally developed in the Robotics Institute at Carnegie Mellon University. Greg is a member of the Traffic Signal Systems Committee of the Transportation Research Board, where he chairs the Technology and Standards Subcommittee. He has a Ph.D. in robotics from Carnegie Mellon University, and he has been working in the area of artificial intelligence and intelligent machines for over 20 years. Now, at this time, I'll pass it over to Greg.
Thanks, Brian. So today I'm going to talk about the Surtrac Adaptive Traffic Control System, how it works with Miovision TrafficLink, and how it can be useful to you in your road networks. Surtrac is the most advanced traffic signal control system on the market. It's a true real-time adaptive system, and I'll talk more about what that means. And we really think that Surtrac, along with Miovision TrafficLink, allows us to optimize for everyone on corridors and grids, in dynamic traffic flows, in real multimodal networks, and even in large, dense urban networks. So the presentation today, I'm going to talk about what Surtrac is, how it works, how it's installed into your signal cabinets, how it operates, how it works in multimodal environments, and then I'll have plenty of time available for questions, and we can cover detail in any area that you're interested in. So Surtrac's goal is the real-time, second-by-second optimization of complex dynamic traffic flows. And it does this by using decentralized control. Every intersection is going to optimize its own traffic control second by second, but then coordinated action. So intersections will work together by sharing information, sharing projections of the future about where traffic is going to flow. And this means that Surtrac is optimizing signals for the actual traffic that's on the road right now. Most other systems are either optimized for the traffic at a period a few years ago when they observed it, or other adaptive systems, maybe are optimized for the traffic 5 minutes ago. And Surtrac is thinking about the actual vehicles, actual pedestrians, transit, bikes that are approaching an intersection and optimizing for them. And this lets us do coordination of signals much more dynamically, so that we can think about coordinating multiple directions of traffic simultaneously, changing the direction of coordinating for not just cars, but modes like transit, which have a different flow, or pedestrians, and really lets us optimize for everyone based on the priorities that you have for your signal network. So if it's a very vehicle-focused network, you can optimize for vehicles. If it's a more urban network and you want to really focus on vulnerable road users like pedestrians and cyclists, that can be the focus. And it can be mixed, so that if you have different types of demands at different times, Surtrac's really going to optimize for what is there and what makes sense for the overall performance of the network. It's also a really easy system to deploy. Because it's decentralized, you can start with small deployments, grow them incrementally as you have funding available, and scale to large networks because it can scale infinitely. There's no centralized computational bottleneck like a lot of adaptive systems, so it can grow to any size signal network. And Surtrac is really ready for the future. I'll talk a little bit about this, but it's prepared now for thinking about things like connected travelers, connected pedestrians, connected vehicles, connected transit, and is really future-proof because it can take in information from those sources along with the kind of passive detection that we use today. So how does Surtrac work? We start out by using traffic sensor data. So for example, from the Miovision TrafficLink system, we're going to use that to sense vehicles, pedestrians, and other modes. And we use that sensor information to build what we call a predictive model of traffic. And this is predictive in the short term, over the next minute or two. It's an aggregate representation of traffic flows from the sense traffic that we can use then to make a plan for how we should operate the intersection. We share information about both our current plan and sensors that we have available to us with our neighboring intersections. That creates a longer planning horizon that allows us to get progression through a network, to be able to respond to traffic that we might not be able to see for a couple of minutes. And then this optimization is a powerful artificial intelligence optimization that is thinking about overall delay. So it's thinking about all the traffic in the network. It's optimizing over this model to create a good plan, but a plan that it can update. So it only actually executes the first couple seconds of that plan by sending commands to the traffic signal controller, but it's made a longer term plan to allow for sort of smooth operation. But then it's working with the controller still managing the signals, enforcing safety and operational constraints. So it's a system that works well in the field and is robust to a lot of things that can happen, changes in traffic. So the key technical ideas behind how Surtrac works. We're treating the intersection control problem as a single machine scheduling problem. We're using this aggregate representation of traffic flows, queues, platoons as input jobs, and then we're sequencing them to create an idea of how to operate the signal. We're using, to achieve coordination, rather than using an offset-based model, we use what we call a vehicle arrival model. So we have a model of when a particular vehicle is going to arrive at an intersection, and that we're planning then for that vehicle's arrival, so that we're not, it's in the context of an overall schedule, not sort of a hard constraint like an offset that might not be based in the reality of traffic. Because of the way that Surtrac works, it behaves very differently in different types of traffic, appropriate to the type of traffic that it's in, without sort of you having to program what that means. So in light traffic, it can focus on platoons without stopping. Its phase durations can vary. It can be very responsive to individual vehicles or individual pedestrians and individual demands. As traffic gets heavier and you get into shoulder periods where your goal is really not to get congestion, Surtrac can really shift more towards managing queues, more defined coordination, really focusing on keeping it out of saturation. But even in networks that get saturated, because we're in some cities where that's inevitable, right? The demand at certain periods of the day is just higher than the capacity of the road. We can really focus on queue management, really heavy emphasis on dominant flows of traffic, and then try to get it back out of that into free-flowing traffic again. And that's been very successful with Surtrac. And this is autonomous, so that you don't have to think about what time of day does this happen. Surtrac is going to detect those conditions. It's always doing that all the time. And that's what makes it very effective and its performance so good. So we have customers in the US and Canada. Since this is focused primarily on Canada, there are a couple active deployments that we have in Ontario, one at the Toronto Premium Outlets, just to the west of Toronto, and then one that's just come online in Peterborough, Ontario, that we're just about to start to do a formal evaluation for. But even when we did a sort of preliminary look at this network, just before we'd really tuned everything in Surtrac, we saw really good improvement, something like 30% for the heaviest flow of vehicles. This is in a network with a lot of Miovision units. There are 89 Miovision units in the network. But Surtrac is at just 6 of those intersections. But it means that Peterborough can then expand that because, as we'll get to later, one of the big things that Surtrac needs is good detection that Miovision TrafficLink provides. So how do you install Surtrac at an intersection? Well, it works with the existing components and or maybe you have to add some of these components, but these are typical components that you expect to see at an intersection. So the traffic signal controller is one, communication within the network, particularly neighbor to neighbor, which is how Surtrac communicates. And then for detection, we really believe that Miovision TrafficLink is the best detection that there is. And so you'll see that in this slide. And then we add a Surtrac processor to run our algorithms, we think about ourselves really as a software product, but it needs hardware to run on at the intersection. So TrafficLink provides communication in some cases. It provides video detection that is really best in class. And it can also provide a lot of other things that are really useful for monitoring the way that a network is performing, and really thinking about how you operate your signals effectively. So the Surtrac processor that's added to the cabinet is designed for this kind of environment. It's a wide temperature computer. As I said, we're primarily focused on the software, so it's really a commodity unit that will work well in the kind of environments you see in cabinets. Now, we use detection that is existing, things like TrafficLink, and then consume that and turn that into good timing plans. And so Surtrac actually interfaces directly with the detector as opposed to going through the controller to get, what look like loops. And this is really powerful. Miovision has really powerful capabilities because we can use pulse zones, we can use more complex zones, we can use pedestrian zones. It's possible to use existing, to continue to have existing zones that are used for conventional traffic control, and those can sit right alongside the zones that Surtrac uses. Surtrac is very widely compatible with traffic signal controllers. We've in both the US and Canada have integrated with various cabinet types, various controllers. When we've worked with Miovision and then even on our own. So typically we're using NTCIP to interface with controllers, but it's designed to be modular. So if there are other types that are out there that are a little bit older, it may be possible to integrate with those too. And then we have a number of international deployments that don't use North American standards as well. So communications is a big part of what makes Surtrac work well. It's a decentralized network, but it's one where you need to be able to communicate between intersections, which means we need a reliable Ethernet network between intersections. Now that can be things like fiber, point-to-point wireless, but we also have a number of deployments that are just using cellular through Miovision TrafficLink. So Peterborough, for example, and Toronto Premium Outlets are both using just cellular for intersection-to-intersection communications. And then backhaul connectivity is required for being able to do ongoing monitoring and operation. But again, Miovision's cellular offering is a really effective way to do this. And we've done this in places in both the US and Canada. So the installation timeline looks a little bit like all projects, but typically when you put in an adaptive system, it has to be the last thing that goes in because you have to have all of the other components working first. Now, so one question I get a lot is, how does Surtrac work with the traffic signal controller? We've designed Surtrac so that the traffic signal controller can be returned to its regular conventional state very easily, and that we're working along with it, not against it, which is different than some other adaptive systems. So we're using a separate pattern in the controller. We're just putting it into manual free, and then Surtrac is controlling phase durations, but then it's very easy to put it back into time of day or conventional control. And Surtrac is designed to be robust to all kinds of failures, things like communication and detection, because nothing is ever perfect on the street. Now we have our own central monitoring system, and this is really, so though it lives in the cloud and is a browser-based interface, you don't need RapidView to work for Surtrac to be adaptive. So if you lose backhaul connectivity, but you still have local connectivity between intersections, Surtrac can continue to operate adaptively without any issue. But RapidView gives you a way to do remote monitoring control, get statistics about individual intersections, about whole networks, to get flexible alerts for when things are not, other components in the cabinet are not working properly. All the kind of things that you want to be able to see to know that your adaptive system is working well and providing you the kind of performance that you want. I'm going to take just a minute to talk about some of the unique things we do around multimodal detection. We really think this is an area where working with Miovision has been really effective. Miovision's TrafficLink is can identify not just vehicles, but also pedestrians, cyclists, transit, other kinds of modes. And because that's possible, Surtrac can pull that kind of information in and really think about adapting to all kinds of traffic, because we're capable of taking a lot of information in, not just sort of calls, but also really richer information about traffic demands. So an example of that where we're working together is in Quincy, Massachusetts, where we're deployed with Miovision, and we have intersections where one of the major demands is just pedestrians. So these are hawk signals in Quincy, and these are operating adaptively, where the goal is to serve both the vehicles that are using the road and the pedestrians that are using the crossing at the same time. And so we're doing this exactly like we would do if we could, at a regular intersection where we maybe just would be detecting vehicles. So this is really pedestrian-centric adaptive. And then what's possible with connected travelers? I think this is an area where there's been a lot of hype around what you might be able to do in the future, but a lot of other systems sort of think about maybe what you could do when many people are using it. We've tried to focus on places where the first person who uses a connected application, it provides them benefit, it provides benefit to the system. So a couple examples of this are PedPal, which is a smartphone application designed for disabled pedestrians to help them interact with intersections more effectively. This was developed with Carnegie Mellon, which the lab that we spun out of, and then we collaborated on this project. And it provides haptic feedback to the blind, but information that helps them use intersections more effectively and more safely. And then what we call transit signal optimization, which is a way to really model transit more effectively in the context of adaptive control, so that we're optimizing for transit vehicles, not just preempting the signal for them. This means that they get better performance, but there's not a limit to how much we can provide them good priority, because it's working in the context of overall traffic. So I'm going to stop there, and we will take some questions. I went through a lot of that very fast, but I think it's very helpful to have more time for questions than it is for to go through me just talking at everyone. So I'm going to turn it over to Samantha, and she's going to read out some questions as we get some.
So someone is wondering, do you modify the max times or force offs in order to manipulate phase durations?
That's a good question. So the way that we're interacting with the controller, we still have a max time. So Surtrac is still subject to minimum constraints, but then we impose a different maximum constraint for Surtrac, but it's still a constraint that's configurable. So you might have a max that's set for time of day, conventional traffic control. We'll have a max constraint as well. And then Surtrac is allowed to go up to that max too. It might be longer. I think in a lot of cases, we like to have the flexibility for some phases to have longer maxes, though that's not universally true. But we use holds and force offs to work with the controller. That's the primarily sort of control hook that we use.
Someone is wondering, do you program your own ring and barrier?
Yeah, so typically we're using the same sequence that would have been there before we were. So really what we're doing is operating under the same constraints that the traffic engineer wants to place on operation at the intersection. Now we can be more flexible if that's desired, but I'd say in most of our deployments, the desire is not to do wild sequence changes, but really to operate the same sequence of phases just in a more efficient way. But it's possible to do it otherwise if that's desired.
Do you collect different traffic signal timings from intersections, or you maintain any fixed traffic signal light timings?
So I can try to clarify this. If you want to clarify your question, I'll try to answer it. And if I don't answer it well enough, let me know. So Surtrac is a completely adaptive signal system. It does not do any fixed timing. It is optimizing based on the actual traffic on the road at any given time. So you can get really big changes in phase durations cycle to cycle Surtrac really doesn't use the concept of cycle in the same way that conventional traffic control does, because we're not using offset-based coordination. But from one cycle to the next, we might serve, it might look very different because we're not having to do coordination in the same way, and so we can be very adaptive. So every intersection does that differently. Every intersection is doing its own optimization, and it's working with its neighboring intersections to create good coordination, but every intersection gets to make its own decisions.
Can you expand on the difference between classic TSP and the transit signal optimization?
Sure thing. I have some slides on this that might be helpful. So, transit signal optimization is really designed to think about transit in the context of overall traffic. So if we're thinking about moving transit more effectively, in my mind, that usually means if we can do that, we can move all of the vehicles more efficiently too. But regular traffic control and TSP as well doesn't really model transit. It sort of provides a hammer that a bus or light rail wants priority, and it either gets it or it doesn't. It doesn't get anything in between. And if it gets priority, that might be bad for the network. We don't really know. So we're thinking about a system to move transit more efficiently, but do it in the context of overall traffic. So what we're thinking about is in the context of Surtrac, we're modeling things as clusters of vehicles, platoons, queues. And so what we want to do is shift those clusters to reflect the true behavior of transit vehicles and mixed traffic, so we can plan ahead and really increase the likelihood of doing a good job for transit. So you saw this very, very briefly in one of my slides, but this is a sort of model of our aggregate flow representation. And if you think about this, we're modeling all the cars, but a bus stops, right? And when a bus stops, if we have a reasonable prediction of how long it's going to be, we can plan ahead for when a transit vehicle actually needs the signal, and we can then shift that. So yeah, so okay, here's the slide on this. So like essentially we can take a bus and shift it appropriately. So then we're planning for something that's more like reality. We can also prioritize clusters, but I think what we see is that we don't really need to do a lot of priority. Just better modeling tends to get you a lot of performance. And then you can add priority around things like, is it late? How full is it? Whatever you want to do, or just sort of always prioritize transit. And really the advantages over normal TSV is that it's really thinking about the transit in the context of all of the traffic. So you can you can prioritize multiple transit vehicles simultaneously instead of just the first one to get to you gets the priority. You can consider upcoming queues. It can really avoid also creating congestion by a transit signal priority event. And there are a lot of ways to do this. I mean, I think one of the places where we're deployed with transit signal optimization is in the Boston area with MBTA, which is the transit agency, and they have an AVL system. We're just consuming their AVL system. They have a bespoke API to do that, but we also have developed one that uses GTFS and GTFS real time, which means, if your transit agency has GTFS real time, we can probably just turn this on, in a Surtrac network, which is makes integration really easy.
Someone asked, how does Rapid Flow optimize for transit vehicles? Does it interface with the bus AVL systems directly?
Yeah, so typically we're interacting with an API that comes from the AVL system. So as I said, GTFS real-time is what you're going to see a lot of places. It's a pretty standard way to do that, and we have a way to do that now. There are other options, interfacing with communication systems directly on a bus. But I think where I see the industry going is, AVL systems on transit vehicles are providing a feed, and we can consume that feed, that API, to be able to get the information we need to do a good job for transit.
What is the optimization objective? Is it in minimizing delay time, or does the system consider optimizing traffic safety, for example, the number of conflicts?
So the optimization objective is minimizing overall delay. Now, there are what we've seen. So there have been studies on Surtrac deployments since the first one we did that shows that improves safety. And I think, but it doesn't really. We're operating in the same context as anything else, where the traffic engineer has chosen the environment that we can operate in, and we're making it more efficient, right? So we're not adding or reducing the number of conflicts. We're doing signal control. But by making it more efficient, we increase driver compliance, make it sort of less frustrating to be in traffic, and thus create a safer condition. But yeah, the objective, rather than being just moving one direction of vehicles like what is typically done in conventional traffic signal control, where you're really only optimizing for the main flow of traffic and everybody else sort of gets whatever time is left over. Surtrac is thinking about all of the travelers in the network. And it's optimizing for overall delay. So a lot of the time that means doing well by the major flows of traffic, but those might shift. And when they change, Surtrac is able to adapt to them.
How many detection inputs do you need? Do you only require a single Miovision camera?
Sure, so I might go into a little bit more detail on this one because I think this is helpful. In general, for most intersections, we do only require a single Miovision camera. But I'll talk about how we use detection because I think this can be useful. Surtrac thinks about detection as being sort of at two locations on an approach. The stop bar, which is detection location 2, and then somewhere in advance of that, which is detection location 1. We look at lane by lane detection, all lanes, both in and out of an intersection. And we really think about splitting those into stop bar as things approach an intersection, exit as things exit an intersection, and then advance somewhere in advance of the network. But one of the things that you find is that exit detection from one Surtrac intersection becomes advance for the next Surtrac intersection, which makes detection very efficient because the Surtrac intersections will just share that information with one another. If you have an intersection that's sort of at the edge of the network where there's no other Surtrac intersection upstream of it, it might use a zone that's sort of further out in the view for advanced detection, or it might use a dedicated advanced detector. And we've done that a lot of different ways. In Peterborough, we're actually using other Miovision cameras at other intersections as advanced detectors, even where Surtrac is not deployed. We've done it with radar, we've done it with loops. There are a lot of options for advanced detection. So if the intersection is small enough, one Miovision camera really covers you for most intersections. We have some, I think like any place where Miovision is deployed, if the intersection is large enough, 2 cameras becomes really beneficial. But that's really more of a intersection size question.
How does the system work after a power outage? If we have battery backup already installed in our existing lights, will this reboot itself and continue to work?
It will. So if there's a power outage when all the power comes back, Surtrac will come back up and try to go back into control. But Surtrac is able to understand when it's not in control of the intersection. So if it's in, if there's a power outage and an intersection goes into flash, for example, Surtrac will wait until it's able to take control properly, and then it will take control. It's also possible to set it up in ways where if you don't want Surtrac to take control after an event like that, it just won't. I think you always see, power outages of all different kinds are something that you always see in traffic networks, and being able to handle those properly. And I think another example other than power outages that might be, I guess, instructive would be preemption, right? So we have a number of places where we have either emergency vehicle preemption or railroad preemption that trigger a lot, right? Our deployment in Portland, Maine has a major rail line that goes through it. And then our deployment in Quincy, Massachusetts, there's a fire station in the middle of the network. So they're constantly preempting, and Surtrac will release control to those systems while preemption events are active, and then it will take back control when it's able to do so. And it's the same thing for power outages.
Do you have statistics or studies that you can share showing how much you've improved coordinated corridors at the macro level and at a micro level LOS at the intersection level?
Yeah, I think this is something that that's, if you reach out to Stinson, both Rapid Flow and Miovision would be happy to provide some of these kind of studies for places where we work together. And I think we anticipate having a report about the Peterborough deployment, for example, available to others at some point soon.
How do you account for mid-block when projecting certain queue arrivals?
Right, so this is a good question. And there's a couple different answers depending on the type of network. So if you have no sources and sinks in between two intersections, then Surtrac is making predictions based on that. But if there are significant sources and sinks, we're often either modeling that with something that's making a prediction, or actually in Peterborough we have a couple of mid-block detectors that are used to adjust detection in the middle of the block. So we can incorporate that kind of information where you have, like a good example of this would be in the Peterborough network. There's actually a Walmart driveway between two intersections. So sometimes a day, that's a significant source or sink of traffic. By adding a detector there, it allows it to be really accurate. Another example of how we've done this is in Portland, Maine. We're around a significant highway interchange. And so you have ramps both onto the highway and off of the highway. By adding additional detection in those places, it can really correct for the significant differences. Now, if you just have a minor source or sink, Surtrac does a good job of adjusting its model based on what it's seeing, right? So it's never assuming that everything is perfect, because nothing is ever perfect. Detection is good, but Surtrac is always trying to adjust its model to what the detection is actually telling it. And it uses redundancy. So if we looked at, when we're looking at detection, we use both pulse zones, which tell us when vehicles pass certain places, but also presence zones as a source of redundancy in detection.
What type of configuration does the signal engineer do in the Surtrac system? For example, maximum sequence, or is it completely up to the Surtrac system to choose the most appropriate operational mode based on the inputs?
So generally, when we set up a Surtrac system, we're working with the signal engineer who operates that signal system to decide what those settings are, right? So we might have some inputs about what we think will be best for Surtrac and its performance, but we're doing that within the constraints placed by that engineer who operates that network, right? So things like maximums, minimums, sequence are definitely up to the engineer who's going to have to operate those signals for the long haul, right? There are going to be places where Surtrac can suggest changes that might improve its performance, but performance is not the only thing that matters here. There are other things that are important. Constraints are in place for other reasons, and Surtrac operates within those constraints in the way that the person who actually owns the network wants them to.
During off-peak and busy hours, do you decide to change the traffic signal timings based on the number of vehicles coming from different intersections? Yeah, so this is what makes Surtrac so powerful, is that it's adapting not just its timings, because I think when you think about timings, people mostly think about sort of split cycle offset type timings. Surtrac is adapting its phase durations in real time. So it may make a decision, I see a platoon of 5 vehicles coming, and then there's a gap long enough that I can switch and serve, maybe this other direction where I know in 10 seconds a platoon of vehicles is going to arrive. It's making those decisions every second, and it's doing that with a really powerful optimization that is able to make really sort of optimal decisions about the way the traffic should flow. So one of the things that's really nice about Surtrac is that in those off-peak periods, when there's
there's still a lot of traffic, but it's not flowing in that sort of defined directions like you get during the heaviest peak periods. Surtrac actually really performs well in those kind of environments because there is no sort of coordination. Doesn't mean the same thing in that heavy off-peak period as it does during the heaviest parts of the peaks. So it does well in all kinds of environments, but I think that's one of its real benefits, is that it doesn't need you to tell it this is the direction you should favor. It's doing it based on what the traffic actually looks like.
Do you have your own exit sequences programmed after a preemption event?
So again, with preemption is something where we are not setting that up. That is something where the person who operates those signals on, and owns them has made those decisions, and we're using those as a, we're going to use those as a guide, as a constraint around how we can operate. I think that's one place where we try to be very collaborative with all the stakeholders when we put a Surtrac system in, because it really is a change in the way that the signals operate. So if there are places where that can be improved, we might make a suggestion, but we don't do that most of the time on our own. That's something where somebody else has made choices that are safety based or and/or operational based that we're going to follow.
If Surtrac manages each intersection locally, how does your system manage a complete arterial roadway? Does Surtrac exchange data between each other through a master module?
Yeah, so Surtrac intersections are sharing information with their neighbors. And I'm going to go to a slide here that I think I showed earlier that maybe will be helpful to understand what's happening. Actually, let me just skip ahead to, I don't really have one that has a great picture of this, but I'll try to explain what's going on. So my local intersection has a picture based on its detection, what's going to happen. And that, can't be that long of a picture into the future. It has, an upstream detector, maybe it's got 30 seconds of look ahead into the future. Its neighboring intersection, though, has parts of the future of my intersection. So that neighbor can share what we call predicted outflows. So what we predict we'll send to me, this downstream intersection, and that gets shared here. But the nice thing about it is my upstream intersections predicted outflows include information from its neighbors, and the information from its neighbors come from its neighbors. And so you can really think about, if you have a big network, you're only communicating with your local intersection, so there's no bottleneck. You don't have to have that master module that constrains, constrains communication or constrains computation. But information is able to flow through the whole network. So if we have an arterial, say that's miles long, information is flowing down that arterial about when vehicles will arrive, and it's a blend of that predicted outflow and the actual sensed data at an individual intersection. So it's supplemented, it gets more certain the closer it gets to now. And that really is it's a really effective way of modeling traffic, because it means that you can have a really good model that's based around the certainty of detector data, but also a long planning horizon that lets you create an environment where you can get good coordination. So, I mean, that's what we're able to achieve really good performance on arterials, but also, if you're not in an arterial, then you can get really good performance in an environment where coordination may look very different. Right, in an arterial, generally your coordination is about moving traffic along the arterial, but then thinking about traffic that's not on the arterial, that's moving, that's turning on or off. But then grids are something that Surtrac just does natively because of the way that model works.
How is the delay measured if we have one central camera and vehicles may exist beyond the camera scope? What are the advantages of this system over the actuated signal controller that uses loop detectors? Okay.
So delay, we think about delay as being the time that a vehicle spends, in a queue or not moving at free flow speed. Delay is hard to measure just in general. But we've developed techniques that do a really good job of measuring delay, and certainly our traffic model looks at delay within that context. So it's essentially, you can think about it as a simulation of what traffic is doing over the next few minutes. The advantage of Surtrac over actuated signal control is that actuated signal control doesn't plan ahead. And I think really one of the reasons we don't all just run our signals free all the time and do actuation and nothing else is that you're sort of guaranteeing that vehicles are going to stop if you're using actuation. So actuation is maybe you get away with, if you do actuated coordinated, you can get pretty decent performance. But Surtrac is not just looking at the vehicles that are already at the intersection, it's planning ahead for the vehicles that are arriving at the intersection. So you can think about Surtrac really almost as an actuated signal system that also adds forward planning into what it's doing, but is doing that in real time, not a 2-year-old view of your traffic.
Are performance reports and the Surtrac dashboard available through the Miovision portal?
At the moment, they are separate. We have some plans to integrate them together, but at the moment, they're both available and they work side by side. So a lot of the things that are available in Miovision TrafficLink can be used to support monitoring or evaluating Surtrac, and Surtrac provides complementary information. So those two things are designed to work side by side at the moment, and that I think that we plan to do future work where they're available in one user interface.
What kind of warranty and support model comes with a deployment?
Yeah, so this is a question about cost and warranty and support, and because we sell through Miovision in Canada, I'm going to kick this question. You should follow up with Stinson, and they can give you some information about this.
Can an operator program Surtrac to skip phases when there is some demand, but not enough to warrant a dedicated phase? For example, a left turn lane with 1 to 2 vehicles in it that could easily proceed during, say, a 10-second green phase instead of displaying a 10-second left turn phase first.
Yeah, so just like you can do that in other signal systems, you can do that in Surtrac, yes. In general, if you want to have a certain type of sequence or a certain type of like skippable phase, Surtrac can do that too. So Surtrac in a lot of places is actually using actuation for things like left-hand turns, because there's no sense in the planning doesn't make sense for a lightly actuated movement. So if you have a couple of vehicles, actuation's a better approach, and then you can set it up so that it'll only actuate if there are a certain number of vehicles in it. For really heavy left-hand turns, we skip we use the term schedule, but we control those phases in the same way other phases are being controlled. So we can set it up in different ways to meet the needs of a certain network.
Do you set a range of cycle lengths to work within?
So as I said, Surtrac doesn't use cycle lengths to do coordination, because it's not doing offset-based coordination. And so we don't really have to constrain Surtrac's cycle length. So instead, what's being constrained is phase duration. So for a particular phase, what's the duration that it's allowed to operate within? Now, this is essentially, if you want to be pedantic about it, that does constrain the cycle length too. So you're thinking, but it's not as rigid a constraint. It means that you can have a lot of flexibility within some phases and not within others. But yeah, in general, you can set Surtrac up to do that. And what we do is we'll do a lot of work to make sure that those are not overly constraining to Surtrac, so Surtrac has the flexibility it needs, while doing the purpose of max constraints are, which is to ensure that if you have significant traffic on one direction, you're still getting a fairness constraint that you feel comfortable with.
Have you tested your system on a 5G environment to find out if there's any significant changes in performance? or do you have any future plans regarding 5G adaptation?
So maybe you could update your question and tell me what you mean by 5G. Do you mean communication with vehicles, or do you just mean communication between intersections? So if the answer is between intersections, there's really no difference. 5G is, we have lots of networks where there's fiber between intersections, so fiber is much faster than any cellular communication. But if it's communication with vehicles, then yes. So I don't have a lot in here about this, but I can, and I think we're right about out of time, but I could talk a little bit about the kind of things we're doing with connected travelers, connected vehicles beyond what I mentioned. Let me just skip ahead to one particular slide. So one of the things that we found is that sharing information, a traveler's route information, is actually really, really valuable to Surtrac. So we have a system called Routecast that can ingest route information, because it reduces the uncertainty of where vehicles or pedestrians or cyclists or transit are going to go. We only really need short-term route information, so it doesn't, and we can throw it away when we're done. So we don't need, it's not really privacy concern, but it produces really, really good performance improvement. So we've done a number of field tests of this with the MPTA in Boston, with Argo AI, an autonomous vehicle company here in Pittsburgh, and then working with the staff of City of Quincy. And we see 20 to 30% improvement for the vehicles that use it, and it helps everybody, because really what it's doing is reducing uncertainty. So this is a way that we look forward to being able to communicate with vehicles to get this kind of information in the future.
We've gone a little bit over the time, and we don't want to keep you too long. So I think if there's any more questions, we will answer them by email as a follow-up. So feel free to still put them in the questions window.
Yeah, I think at this time, I would just like to thank Greg for doing this presentation. And yeah, we've gone a few minutes over our time limit, but feel free to reach out to us with any questions that you might have. Thank you, Greg. There's our information there on the slide. And again, this webinar has been recorded, so we will be sending that out to the attendees as well. But yeah, thank you very much for your time, and have a great rest of your day.
Thanks, everyone.